Now we move on to the last part. We talk about forces affecting forces, the one changing shape and size. In this case here, we are actually referring to pressure. Pressure is something that we have actually touched on in lower sec. What's the formula? Pressure equals to force divided by area. It's actually the force per unit area. The unit for pressure is in Pascal. For force, the unit is in Newton. And for area, the units is in meter square. So take note of the SI units over here. So how do we go about calculating pressure? It's just relatively simple. So we always say that calculate the pressure of a 100 Newton force acting over a maybe 2 meter square area. So the pressure is equivalent to, so you can see the force is here, the area is here, 2 meter square. So this is equivalent to 100 divided by 2, so it's 50 Pascal. Okay, generally easy. However, let's try a separate diagram. Okay, this is something that has appeared in one of the past year papers. Okay, you have two different piston. Okay, piston 1, piston is like you can just think of a syringe. Okay, piston 2 over here. Now you must first think of it, how does it work? Okay, normally there should be some fluid inside here, some fluid. Okay, now how does it work is that when piston 1 pushes down, what happens to piston 2? It moves up. When piston 2 pushes down, piston 1 moves up. Okay, this is generally how it works. Relatively simple. Okay, so but let's try to do some calculations based on this. Let's just say this platform here has an area of 2 meter square. This platform here has an area of 1 meter square. Now, what's the pressure exerted? Okay, what's the pressure here when I put down a force of 100 Newton? Okay, when there's a downward force of 100 Newton. So the pressure here, okay, pressure at piston 1 is equals to 100 divided by 2, which I calculated just now, 50 Pascal. But now, let's check, how does it affect over here? Okay, so I push down 100 Newton over 2 meter square. What's going to affect, how does it affect piston 2? Now, what is the same between both of them? If I apply a force downwards here, in actual fact, what I'm doing is exerting a pressure on this side. So the pressure here and the pressure here is the same. So the pressure at piston 2 is also equals to 50 Pascal. Then you must be saying, so what if the pressure here is 50? How does it affect? Let's take a closer look. So if I say that the pressure is 50 Pascal, let's find out what's the force. Okay, let's find out what's the force exerted here. So I know that 50 is equivalent to the force divided by the area. The area is 1. So what's the force experienced at piston 2? It is 50 newtons. You can see that over a larger area, okay, you can see that I can actually exert the force actually here is reduced because of the surface area over here. So piston works in such a way that because of the different surface area, the force exerted is different. Okay, this is how you can apply your pressure. So this is a slightly more complex question with regards to pressure. But I need you all to know that when you have a diagram that looks like this with two different pistons, okay, when what is the constant for this is actually the pressure. Okay, the pressure is the constant here. Okay, so generally pressure, you just need to know the formula, and you must know how to use the formula over here, and also know how to deal with questions, okay, with regards to pistons or looking something like this, knowing that the pressure is the constant. Okay, so that's all for pressure.